Hey guys, so my name is Mpontlangote, and today I'll be demonstrating a project I made for design project, and I will be explaining the final workings of the project with the help of this poster right here. Um, so to start things off, uh, my project is about actually a fan. It's based on Arduino. It's a rotating fan of sorts. Uh, the fan will work in such a way that when the temperature reaches 25 degrees in the room, the fan will turn on, and with the help of the two ultrasonic sensors and the servo, the fan will rotate and face the direction where the object or the person is. Okay, so let's come closer to the page and let me try to explain it. um since the project is about a rotating fan, okay, in the beginning I found the Arduino code for two ultrasonic sensors. I just added an LM35 temperature sensor uh so that it will be the switch of the whole project, so that when the temperature reaches 25 degrees and above, the fan and the whole circuit will turn on. I also added the 12-volt DC fan, the main component of this project, and also a servo to control the direction the fan will face. And by making use of the two ultrasonic sensors to the project, that will they will determine the direction that the servo will face and control the switching on and off of the fan. Okay. I also added a power supply of 9-volt battery controlled by the relay to power the DC fan. I also used the 3.3 supply voltage from the Arduino and added it to the 9 volts to at least try to make a total of 12-volt source for the DC fan. Okay. Now on to the block diagram. So as you can see here, our main part of the project is the microcontroller that controls everything, the Arduino Mega. Okay, the components for this project, actually the inputs, the ultrasonic sensor, actually the two ultrasonic sensors and the temperature sensor, right? The output will be the LCD display, the servo, and the relay that will control the powering on and off of the 12-volt DC fan through the 9-volt battery. The USB supply that will supply power to the Arduino. Okay, so this project will function in the following manner through the flow diagram. Okay, the inputs are the first ultrasonic sensor, the second ultrasonic sensor, and the temperature sensor, as we've said before. The output will be the servo, the LCD display, the 12-volt DC fan, and the relay. Okay, so first, our project will start by displaying the temperature that is measured by the LM35 temperature sensor on the LCD display, and then we will head on to the decision right here, where we will test whether the temperature is greater than 25 or not. So if not, we will head on back to the start and test our inputs and outputs and then display the temperature once more. But if the temperature is indeed greater than 25, that means yes, the relay will be triggered and the fan will turn on. And then after turning on of the fan, we will go to another decision, whether distance 1 is greater than distance 2. This is for the direction of the servo, right? If distance 1 is greater than distance 2, okay, the servo will turn 45 degrees. So that means there will be an object in front or a person in front of the first ultrasonic sensor. Okay, and if not, then the servo will turn to 150 degrees. Then there will be a person in front of the right ultrasonic sensor. Okay, and when the servo has turned and the fan has faced the right direction, everything will go back to start, and then the process will go on once more in a loop, well, at least until we pull the plug and the code will end and the project will stop. Okay, as we head on over to the schematic of the final project, we can see our LCD down here. Here is the temperature sensor, the two ultrasonic sensors on this side. Here is the DC motor, the 12-volt fan. It's a motor, so there it is over there. And then we have our servo right here, and the 9-volt battery that will power this 12-volt DC fan connected to the relay. Okay, and our microcontroller, the Arduino Mega. And as we go on, this will be my PCB design that I designed using the freezing app. Yes, it's quite lovely actually. And then this will be an image of the final project as it's completed. Okay, so let's now head on to test how the final project as assembled will function. Thank you. Okay, so as I've explained how this project will function through the flowchart and the block diagram, I'm going to demonstrate how the project functions in a real life situation. So as you can see here, we have the servo under that is carrying the 12-volt fan, the two ultrasonic sensors, and an LM35 temperature sensor, and an LCD display that displays the temperature that is measured. Okay. So underneath we have our Arduino and the 9-volt battery that is connected to the fan by a relay, right? So as you can see here, the temperature that is measured by the LM35 is 18 degrees, 17 rather. It has not yet reached the temperature needed for the fan to turn on. Okay, so when the temperature sensor measures temperatures above 25 degrees Celsius, right, the whole circuit will turn on. The relay will connect the fan and the battery, and the fan will turn on. These two ultrasonic sensors will turn on as well. They will measure the distances. They will both measure the distance, right? And the two distances will be compared, and whichever ultrasonic sensor has the smallest distance, the fan will turn towards it. So when this distance is smaller than this one, the fan will turn towards to the left, and when this distance is smaller than that one, the fan will turn to the right. So I'm about to apply heat to the temperature sensor so that will increase the temperature to the temperature we want it to be. So sensor. So let me apply heat to this temperature sensor here. Let me go this side. So as you can see, the temperature reached above 25 degrees, and we are on this left ultrasonic sensor, so the fan will turn towards this particular ultrasonic sensor. But as soon as we come to this ultrasonic sensor on the right, the fan will turn to the ultrasonic sensor on the right, so it can go back and forth as we wish without any real consequence at all. So as you can see, the project is functioning properly. So as the distance changes, and so does the direction of the fan. Yeah, temperature is above 25 degrees Celsius. The LCD will show us the temperature, and the two ultrasonic sensors will keep on functioning and measuring the distance and comparing the two distances, and whichever distance is the smallest, the fan will face towards that particular ultrasonic sensor. But as soon as the temperature drops under 25 degrees, the whole circuit will turn off except for the LCD display. The fan will turn off, the two ultrasonic sensors will turn off, but the temperature sensor and the LCD will keep on working to indicate, to show us actually that the circuit is in a loop. So yeah, the project works as intended and as I have explained. Thank you for watching.